multiplying decimals by decimals. We've talked about multiplying whole numbers by decimals, and now we're going to take it a step further. Multiplying a whole number by a decimal might look like this: 5 groups of 14 hundredths. In order to figure out how much 5 groups of 14 hundredths equals, you can count them. And we know that these are 10, and each of these are 4. So I have 20 and 5, which is 70 hundredths. We also, at the end of the last video, talked about the rule for multiplying decimals. If you're making a model, isn't something that's doable at that point. Sometimes it helps to learn to make models so you understand what you're doing, and then you use the rule to make it easier. So we're going to come back to this problem after we've reviewed the rule, and we're going to see what happens when you change this 5 to 5/10. This says anything times 0 is 0. We know that. Anything times 1 is that number. So anything times a number between 0 and 1 has to have an answer that is, you fill in the blank. Let's think about it one more time. Anything times 0 is 0. Anything times 1 is that number. So anything times a number between 0 and 1 has to have an answer that is between 0 and 1. Let's see if it's true. 3 times 0 is 0. Let's pick here to do 3/10 times 5/10. Let's see if I can write this 5 legibly. There we go. Well, 3 groups of 5/10 would make 1 and 5/10. So 3 groups of 5/10 is 1 and 5/10. 3 sets of 50 cents is $1.50. So let's use this same rule and figure out what it does over here. 3/10 times 0 is still 0, and 3/10 times 1 is 3/10. So both of these rules work. Anything times a number between 0 and 1 has to have an answer that is between 0 and 1. So this says 3/10 times 5/10, which doesn't necessarily mean 3 groups of 5/10 anymore. It's 3/10 of a group of 5/10. The easiest way to think about what it really means is to think that you have 50 cents. You break 50 cents into 10 groups, and you take 3 of them. So 3/10 of 5/10 is 15 hundredths, or 15 cents. Let's look at a diagram of it. This says 3/10. And if this represents 3/10 and I have to take 5/10 of it, I would have to break this into 10 parts. And I can do that like this. 3/10 broken into 10 parts. So each one of these lines represents a 10th. And then this says 5/10. So I might color 5 of them. And the answer would be, how many of them are colored with this brown? And the answer would be 15 hundredths. We're going to look at these diagrams a little bit more, but here are some more diagrams to show you what multiplication of decimals looks like. The orange shows 4/10. This says 8/10. So I colored 8/10 in the opposite direction. And the answer to this problem is going to be the amount of squares that are colored. So 4/10 times 8/10 is 32 hundredths, because there are 32 that are colored with both orange and green. Let's do this one together. 2/10 times 3/10. 2/10 is already modeled, colored vertically, so I'm going to model 3/10 the opposite direction. That's 1/10, 2/10, 3/10. And my answer is the amount that are shaded with both colors. 1, 2, 3, 4, 5, 6 hundredths. So we've modeled these multiplication problems. Now let's look at some patterns and then a rule. This one we can do because it's 6 groups of 2/10. 6 groups of 2/10 is the same as 1 and 2/10. 2/10 times 6/10 is 12 hundredths. 2 hundredths times 6/10 is 12 thousandths. Now, before I finish these with help from you, this is another part of our song that we learned about adding and subtracting decimals. Same tune. Multiply means count the digits behind the decimal. Multiply means count the digits and move the decimal. Multiply means count the digits and move the decimal so that these match. We want them to match. We want the decimals in the product to match the decimals in the factors. So let's use this rule and count the digits behind the decimal. We counted them. There's 4. We're going to write 2 times 6 is 12, and then we're going to move it 1, 2, 3, 4. And then we check to match. 1, 2, 3, 4 here, 1, 2, 3, 4 here. Again, we count 1, 2, 3, 4. 6 times 2 is 12. 1, 2, 3, 4. So, multiply means count the digits behind the decimal. And then, after you've counted the digits behind the decimal, multiply means count the digits and move the decimal. And then finally, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 digits behind the decimal. So, let's use those rules and do some practice. If the rule for decimal multiplication is count the digits and move the decimal, this says correctly place the decimal. So let's do that by identifying the digits behind the decimal. There's 1 in the problem, so there should be 1 in the answer. And remember, these are all written as whole numbers, so you must assume that there is a decimal at the end of every whole number and then move the decimal from the right. So we're going to identify the 2 that are here and move the digits, move the decimal twice. Circle every digit behind the decimal and move it 1, 2, 3 times. Let's do one more. Let's identify the digits behind the decimal. 3, 4, 5. And I know that 25 times 8 is 200. Well, what am I going to do? Because there are 5 digits behind the decimal and only 3 in my answer. 1, 2, 3, 4, 5. Simply follow the same rules. So my answer is 2 thousandths. These want us to identify the multiplication problem that goes with them. This is 3 identical groups of 12 hundredths. So this problem could be written 3 times 12 hundredths, which means that I could multiply 12 times 3 and get 36 and count the digits and get 36 hundredths. Or because I have it modeled, count 10, 20, 30, 32, 34, 36. Let's try the problem for this one. There are 2 tenths this way, so that would be the first number in our problem, 2 tenths, and there are 4 tenths this way, so times 4, and there are 2, 4, 6, 8 hundredths that are shaded. Place the decimal in these 2 brown ones. So we're going to count the digits behind the decimal and then move the decimal that many places. Count the digits behind the decimal, 1, 2, 3, 4, and move the digit that many places, 1, 2, 3, 4. Now, this answer would still be correct if the 0 were not there. These say solve. So, multiply means multiply as normal, 2 times 8, 6 times 105, and 25 times 4, and then move your decimal. So, 2 times 8 is 16. 1, 2, 1, 2, 16 hundredths. 6 times 105 is 630. There is 1, 2, 3 digits behind the decimal. 1, 2, 3 digits behind the decimal. So 630 thousandths is the answer, but 63 hundredths is the most common answer. 25 hundredths times 4. 25 times 4 is 100, so 25 hundredths times 4 tenths is 1, 2, 3, 1, 2, 3, 100 thousandths. Alright, the last one was this word problem. Steve buys 2.5 pounds of apples at $3.25 a pound, and he also buys 2 bananas at 29 cents each. How much does it cost in all? Well, first, we have to multiply 2.5 times 3.25. First, we're going to multiply 2.5 times 3.25, which I happen to know that 25 times 325 is 8,125. 1, 2, 1. So 8.125 is what he paid for the apples. 2 bananas at 29 cents each. So 29 times 2 is 58. And there's 1, 2 behind the decimal, so 1, 2. So now he's going to pay 58 plus 8.125. So 8.705 is what we got when we did the math. But this is not a price. So in order to be correct, you would have to do what the grocery store would do and round that to the nearest penny. So this charge at the grocery store would be $8.71.